Good morning, dear students. Our discussion is now regarding dispersion of light. It is one of the most important phenomenon of optics, dispersion of light. Actually, dispersion of light takes place when a white light, say a white light, this is a white light, ray of light A, B, is incident on the surface of a prism. And when a white light is incident on the surface of a prism, during passing through the prism, the light is refracted, and during refraction, the light splits up into its 7 constituent colors. These are the 7 constituent colors, that is violet, indigo, blue, green, yellow, orange, and red. And a white light is a composition of 7 colored light. It was first discovered by Sir Isaac Newton. Isaac Newton observed it and he made a wheel. The wheel was made of 7 colors. And when the wheel was rotating, 7 colors disappeared and white color was seen. And from this, Newton concluded that a white color or white light is a composition of 7 colored light or 7 colors. This phenomenon is called dispersion of light. So now what is dispersion of light? Now we like to write the definition of dispersion of light. The phenomenon of splitting up of a polychromatic light. White light is called polychromatic light because it is made of many colors. Polychromatic, you can say white light into 7 monochromatic light. These lights are monochromatic lights, single colored light. After being refracted by a prism is called dispersion of light. Now again see, it's a phenomenon of splitting up of a white light or polychromatic light. This is a white light. When it passes through a prism, it splits up and then a band of 7 different monochromatic colored light is formed. The 7 colored band is made of violet, indigo, blue, green, yellow, orange, and red. This 7 colored band is called spectrum. So what is spectrum? Spectrum is a 7 colored band or a band of 7 monochromatic light. Actually, it is a band of 7 monochromatic light, violet to red. When a white light passes through a prism, gets refracted, a 7 colored band is formed, that is called spectrum. Now in the spectrum, it's a pure spectrum because pure spectrum is that in which the 7 monochromatic lights are seen separately, distinctly in their own position according to their refrangibility. According to refrangibility, the position of violet is at the bottom and the position of red is at the top. And this happens due to the different wavelengths of different colored light. Actually, wavelength of different colored light in vacuum is same, speed is same, and therefore no dispersion takes place in the vacuum. But when it passes through a prism or prism-like refractive substance, the phenomenon of splitting up of a polychromatic white light into 7 monochromatic light after being refracted by a prism, and you can say prism or prism-like refractive substance like droplets of water, etc., is called dispersion of light. So during passing through a prism, the speed of different monochromatic light will be different, and therefore their deviation will be different. The deviation of violet is maximum and that of red is minimum, because speed of violet is minimum and speed of red is maximum. So when speed is greater, then deviation will be less, and when speed is less, deviation will be greater. Due to their different deviation, they splits up, and then a 7 colored band is observed or seen, and this 7 colored band is called spectrum. Now the spectrum can be defined as the band of 7 monochromatic lights produced by the dispersion of white, that is polychromatic light, is called spectrum. A spectrum has 7 monochromatic light, that is, in the light there are 7 colors. These 7 colors are vivid here. Vivid here you have already seen: violet, indigo, blue, green, yellow, orange and red. So the terminal colors are violet and red. These are the terminal colors, keep in your mind. And among these 7 colored light, red colored light has maximum speed, so its deviation is minimum, keep in your mind. And violet has minimum speed, so its deviation is maximum. And then you can arrange this in this manner: violet to red, that is ascending order of speed. The speed of indigo is greater than violet, and blue is greater than yellow, indigo, and such up to red. Red has maximum speed. So this is regarding spectrum. There are 2 types of spectrum. One is pure spectrum, and another is impure spectrum. What is pure spectrum? The spectrum in which 7 colors or 7 monochromatic lights are arranged separately and distinctly according to refrangibility in their own position is called pure spectrum. So keep in your mind 3 words: separately, distinctly, and in their own position according to refrangibility. But in impure spectrum, the 7 colored light or 7 monochromatic lights are not arranged distinctly, separately, according to the refrangibility in their own position. This is impure spectrum. Normally we cannot get a pure spectrum. The example of impure spectrum is rainbow. It is impure and it is a natural spectrum is rainbow. What is rainbow? Just after completion of rain, when rays of light coming from sun gets dispersed after passing through the droplets of water, a few droplets of water float in the sky after completion of rain, and then the sun rays passes through the droplets of water, and then the rays get dispersed and impure spectrum is formed, and this impure spectrum is rainbow. So keep in mind that rainbow is impure spectrum and it is natural spectrum. Pure spectrum cannot be found in this manner. Pure spectrum can be formed artificially by using prism, convex lens, slit, screen, etc. And you keep in your mind the difference between pure and impure spectrum. Difference is that in pure spectrum, the monochromatic lights are arranged distinctly, separately, and in their own position according to refrangibility. In impure spectrum, the 7 colors light are not arranged distinctly, separately, in their own position according to refrangibility. In pure spectrum, the 7 monochromatic lights do not overlap each other, so they are seen distinctly. But in impure spectrum, the 7 monochromatic lights overlap each other, so they are not seen distinctly. And this is all about the spectrum. Now we have completed spectrum and dispersion of light. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.